All right, everybody. Hope you're back. Welcome back. We're going to be doing something a little bit different this time. So, Quinn, who I have on the line with me, and I'm sorry. Give me a second. Wow. Everything. I think it was actually Discord that messed this all up for me.
It's always just hard.
So, Quinn has implemented some Datalog in not in Haskell, in Rust before. And a few years ago, I took this blog post, which we'll look at, the essence of Datalog, and implemented naively evaluated Datalog in Elixir. And you're like, oh gosh, what is this thing? What is this weird thing? Datalog is a really interesting and incredibly simple language. And I don't know, Quinn, like, what do you think Datalog's really good at? What is it used for?
So I think there's two answers to that question. There's what is it actually used for nowadays?
Yeah.
And that is primarily static analysis. Uh, it shows up a lot in both like security, reverse engineering, and like more PL-centric static analysis. There's
Hmm.
a lot of really interesting properties around the language that do things like guarantee termination and make it really useful for doing things like reasoning about the behavior of loops in a program.
Hmm.
So there's a variant of Datalog named Souffle that's pretty much designed for static analysis, and that's where the language sees most of its use. But it first showed up in the 80s as sort of like the intersection of artificial intelligence, databases, and PL.
Hmm.
And there's a couple interesting streams of research that are trying to kind of repurpose all of Datalog semantics in distributed systems. So that's where a lot of my focus with the language came from,
Yeah, that's awesome.
mostly implementing and reasoning about things like Raft and Paxos and
Hmm.
all these traditionally really challenging algorithms.
Yeah, and I think one of the things I like about Datalog is it's got a very, I would say, familiar way to represent data, at least familiar to me. Anyway, the it reminds me a little bit of relational algebra, and I think
Mhm.
that a lot of the research probably in the 80s was around. You mentioned databases. It's definitely
Yep.
related to that. So like, anyway, what I want to call your attention to is I have this, folks on the stream. Not Quinn, she knows. I have this Datalog Elixir repository, and it refers to this blog post, the essence of Datalog. And this author wrote this implementation of Datalog in Haskell. So this is sort of what Datalog looks like when it's written in its traditional syntax. You have relations, as I suppose that's the right word, Quinn, right? Um,
Yeah.
so advisor
I
is a
used to think of
relation.
Datalog as being like SQL with recursion.
Yeah,
So
yeah.
you think of like relations as tables and atoms as rows and things like that.
Right, right. So I kind of like to think of these are facts and these are relationships. So things that sort of look like functions or implications. Um, and you'll note here that like you can have similar to what we've been doing in Elixir, you can have multiple instances of even things that look like implications, not just facts. Like, these obviously you would make no sense to have this first line in the program twice, because it doesn't add any new information. Um, but you can take these sort of like patterns or prologue statements. I forget what the word is in prologue. Maybe it's relations. But you could say this basically is saying, um, the definition of an academic ancestor is that person directly advised them, or there is a relationship between someone advised, so X advised Y, and then eventually somewhere down the line Z was another ancestor. So you can think of this as, like you said, like recursion. Um, so this part could be expanded again to either directly, you know, this clause, or it could expand to another one of these. God, it has relationships to grammars too, obviously in this. But you've got it looks like a right recursive rule in
Yeah.
in a grammar. So then similar to Prolog, you can do these sorts of queries like what is an academic ancestor relationship where the intermediate person is between Robin Milner and Mr. Castron. So that's the sort of thing that you can express in Datalog, and it's really interesting. And I thought it would be fun to do it in Rust because I haven't done anything in Rust on stream, even though I do a lot of Rust at work. So we're going to try that, and we are also going to play with the collaboration features on Zed. So
I'm excited for that.
yeah, me too. It should be fun. Okay, so I'm gonna make cargo new. We'll
Actually,
just
just a historical note, Datalog was actually just like a subset of Prolog that people sort of ended up naming Datalog. So the connections you mentioned with grammar are like deep and very rich because most of Prolog's use was around generative grammars.
Yep. Okay. We are not intending to publish this crate, but I do need to make a repository. Okay, so it's got a repository. Let's make one. Make a new repository here. Why did you make it hard, GitHub? Moved everything around. So I'm gonna call it Datalog Rust, and an implementation of naively evaluated Datalog in Rust. Okay. And we are not going to do any of that yet because we have the stuff generated from cargo. Let's copy that out here. Remote add origin. Okay. All right. Let's go ahead and add this, and then I'll get Zed going, and we can. Okay. I'll come in and push it. Okay. Okay, so we've got our basic repository up here. Nothing in it yet. And let's open code Datalog. Where'd it go? There it is. Okay, and then we're going to do the fun new features. We're going to invite Quinn, and I'm going to mute all that. And
Cool. So I'm in there.
cool. Okay, and it looks like you're following me, or you weren't, but yeah.
I am now.
Okay, so we're going to put everything in lib.rs. Let's just start. Hello, Twitch. Let's just start by deleting everything in there. And I feel like we could. Yeah, let's go back to here because and look at the blog post as well, because I think that there's a lot in here that we can kind of crib in Rust a lot better than we could in Elixir. And so we can kind of take some of these types and then just rewrite them as. So I'm going to copy this stuff and we'll rewrite it as Rust. Yes, none of that works. Okay, so we'll say, let's just make everything pub. Rule, that takes a head, which is an atom, right?
Yep.
And a body, which is a vec of atoms. We'll just do pub on all that. And interestingly, rule does not derive equals. Yeah. Let's derive debug though. I tend to put clone on everything as well. I'm not sure if we're gonna need it, but thank you. You're so
So we're just
fast.
gonna are we just gonna match what the blog post is doing and just do like variables and symbols?
Yeah, yeah. Let's just do variables and symbols. I don't think that
Sure.
there's anything like that we want to go farther than that because we. I just want to show that we can um, do the algorithm. Yep. And what's going on
We
here?
need partial loop.
Right. Oh,
This
debug.
would be derived. Oh,
You're
sorry, I'm
getting
stepping
ahead of
over you
me.
there.
Mob programming is fun. Okay, so we've got those types, and we could probably start to construct things like this. Now, one thing that I'm wondering about is should we make these tuple structs instead of named fields? I'm not sure yet. Um, it might make it easier to do something like this. Although that's sort of, I don't know, Haskell weirdness. Okay.
I'd honestly probably leave those fields in
Hmm.
Rust Analyzer. It makes it easy to swap later.
Yep. Very true. Cool. Thank you for making those pub.
Mhm.
So so we need to have uh, program type, knowledge base type, and substitution type. And I think that it might make sense for these to be new type structs so that we can add methods to them later. I was thinking about that
Yeah, that sounds good.
over the weekend, but so this is a Vecca rule according to them. Yep.
Vec of rule. Yep.
And knowledge base is Vec of Atom, and substitution. Hmm. This is interesting. I think we should probably go with Vec of pairs of terms, but we might be able to do something like, and I think it's because the order matters here. Um,
Yeah, so this is something I wanted to ask about actually, because like most traditional data logs are just tuples, but tuples are kind of a pain to work with.
right.
And I wasn't sure if you wanted to leave things as tuples or give them like named columns.
Oh, like substitution would be.
So like Atom, instead of just being a vector terms, it would be like a hash map from like column names to terms or something.
Hmm. Um, I think we shouldn't stray because
Okay.
this um, in the examples he gives here, the order does matter, and like there's no
Yep.
names on these atoms here.
Sounds good to me.
Okay, right. So we could. Yep, very good. You're doing it all for me.
How do you spell substitution? I think that's right.
Yeah.
So we were just going to determine terms, you said?
Yes, vec of term to term. Yep. Okay, so now we've got the base types in there. We could probably start to, and I actually think it might be worth writing out his example here.
Yeah. I'm just going to derive default on substitution
Yep,
2 instead of empty substitution.
and I think we should do it here as well. The knowledge
Yeah.
base, yeah, because we're going to want to start with an empty one. Um,
So do we want to write like a test that tries to write one of these programs? And it doesn't need to do anything yet, but we could just set up the program in there so we're at
yeah,
least.
yeah. Let's make a test. Make a test module. Config test. And test. I don't know if you do it this way, but we'll just say
Yeah.
example.
And usually in here, I will do like use super
Yep.
star.
And I'm gonna copy paste this in, and what we'll do is we'll try to construct that this
Sure.
program.
I
Um,
forget, does the blog post differentiate between facts and rules, or is a
no,
facts just a
it's
rule
saying
with an empty body?
yes, exactly. So a fact is a row
Okay.
with an empty body. So what we can do here is, it'd be interesting to see if we can do something with like into and from, but maybe we'll get to that
Mhm.
later. So let's try to. So this is a program. Let's just let whatever. Okay, and then we have a vec, and the program has a vec over rules. So the rule. So we have a rule, and the first one is the head is Atom, and Atom is a struct as well, right?
Yeah, Atom is a struct, pred sim in terms.
Yep. This is going to get tedious real quick. Um, Maybe we should have gone the route of implementing a parser. um, and then,
I'm weird, but I always love to start with the parser. It's like
yeah,
meditative, makes me think about what I'm actually going to be implementing.
and terms is NOTPEC. And we could actually do like default there. Okay, so no, this is not right. Rule. So this is the predsim is not this. I got this wrong. The predsim is advisor, right?
Yeah,
And the terms are
the terms are going to be term sim standardized and term sim miscontrasted.
yeah. Um, I wonder if we could do something like to save ourselves some time and some typing, make these static stir instead of string.
Yeah, we could also. I don't know. I usually on my constructors I just have it taken as ref stir, and then
Mm-hmm.
I can pass whatever I want in.
Hmm. Okay. Well, let's maybe do a few of these and just see if our
Sure.
compilation works. Yes, Sam, definitely an opportunity for a macro. Yep. Okay. And so that this was the Andrew Rice two string, and then we have another term sim and the Mistral contrast and the author of the blog post. Um, okay, that's getting out of hand. Formatter, thank you.
We
Okay,
could also just make an array of the pairs and then iterate over that and turn it into the facts.
that sounds good to me. So let's do that. Advisors.
And
You
I'm
want to
just
do
going to
that?
start iterating over that. So I'll just say like, I don't know, let facts equals advisors dot. I'm just going to pretend this exists.
Okay, and in the meantime, I'm just gonna like take care of the stuff up here and just like make you pairs of static strings.
Sounds good. Is it advisor and then student or student and then advisor?
Um, it's
Who
advisor
is Andrew
student.
Rice's advisor? Advisor student?
Yep, because it recurs
Is that
to
how
the
you
right.
spell advisor? Or is it an OR?
Well, I don't know. They're using the British spelling.
Okay.
Okay. Cool. And I think that's a Vecco rule. What's going on here? Oh, it's missing body. So these are facts. So
Oh yeah.
body is empty vec. Or we can do the tricky thing here.
I think there's a mismatch. Yeah. I have too many curly braces.
Yeah, that actually doesn't implement default. I'm sorry, I can't do that. So we'll just do body is vec.
Yeah. And default might not semantically make sense there.
Oh, it doesn't for rule. It definitely doesn't for rule.
Yeah,
It doesn't for Atom either. So yeah. Okay. So now we can say
I'd say we could also do like rules equals to do, and then the program can just be made up of uh, facts concatenated with rules,
yeah.
maybe.
Do we have to do mute facts then?
Oh yeah,
Or is yeah? I don't think there's concat. I think you have to extend. Um,
extend. That's it. That you
but extend doesn't return the value; it just mutates it. So
right.
it's all right. We'll go with we'll say facts, and then we can have something in here that is facts dot extend rules.
Sounds good.
Okay, unreachable statement.
Yeah, I just have to do here on the rule
Oh, right,
since you
right.
haven't filled that in yet.
Yeah, let's go ahead and do that. I think that's simple enough. Yep. So, oops, I'm not quite used to this collaboration mode. Sometimes it jumps the thing around. Okay, so we
Yeah,
have
it's mainly an issue if we're working on the same line.
right. Uh, okay, so we have this bit, right? Yeah. So we
Yep.
can say, and I have this up here. Why don't I just copy and bring it down? Because we did the individual facts already. Okay. Um, let's use that Rust analyzer. So Atom, fill
And
struct
the pred sim is
fields.
going to be academic ancestor, and then the terms are going to be two term vars, x and y.
Right. Do string. Okay. Let's save and get some help here. Okay. Vec. And this is term sim.
Term var.
Var. Yes, that's right. And x to string term var y to string. Okay. And
Yep.
then body, we
So this first
have
one will be a vec with just a atom advisor with xy as the terms, and we can just copy that from the head.
yeah, and I think we can do this bit. Oh, I see
Yep.
what you mean. Yeah, copy this. So that's actually a place where like I might have used clone.
Yeah.
Okay, so we have one of the rules, and I think that this has enough similarities that we want the second rule to follow
Yep.
from that. So this one is x and z,
Mm-hmm.
right?
And then
And
the
then
first body term is the same.
is x and y, and then we have another body term.
Oh,
Oh, whoops.
yeah, you want this curly or the square bracket out here.
Did I mess that up?
Yeah, it fits it though.
Okay. Fill struct fields. There we go. Okay, so this is this. Yeah, let's copy that actually. That's useful. And then this is y and z. Yes. So we have x and y as advisor and academic ancestor as y and z.
Yep.
Okay, so at least we can construct this program, Datalog program, in its AST basically. And we can tell from the Rust analyzer that it compiles, and we might as well just run
Mhm.
cargo build cargo
Did you
test.
explain what this program actually does?
Right. So this is sort of the family tree type thing, but
Hmm.
with academic advisors. So what this is saying in his example here is that person A advised person B, and so it's kind of like, I don't know, the Erdos number or something, but it's like, so who, you can find who are all the people who advised person B, or you can find who are all the people that is related to that person through that the advisor advisee relationship.
Mhm.
Um,
Basically, the way you can think of it is this academic ancestor is like constructing the tree of all of the advisor relationships, and that's a
mm-hmm.
directed graph over like the advises relation.
Yep.
So X advises Y, but Y does not advise X. And it's essentially going to compute all of the paths in that graph from any point,
Mm-hmm.
and put those paths into the academic ancestor relation.
Yep. So you can imagine that this sort of recursive thing um, is going to generate facts that look kind of like this, but they say academic ancestor as you continue to evaluate it. So eventually you will have all known facts within this program,
Mm-hmm.
and you won't have to apply the
Uh,
rule
so,
anymore.
mhm. And that's basically how we're going to evaluate it.
Yep.
Uh, just run it once, get a bunch of new facts, or a bunch of new, let's call them tuples because facts is kind of a special connotation here. But compute some new tuples, put them into the relation, and then just keep reevaluating
Mm-hmm.
that rule until nothing changes.
Yeah, and so we're not going to do any of the optimizations that tons of researchers have figured out how to make this more efficient. We're just going to reevaluate the entire program until we hit a fixed point. Yeah, so that's what this blog post is about. Um, so we got through the types. Um, so empty substitution. We basically had default on substitution. Okay. So now we need to get into the nitty gritty. Um, and I'm probably going to run out of screen space, but that's okay. We'll do our best. So we could make a function that does this. Um, Note here they're doing some stuff with closures, and I don't really know that I feel like I like this. And this also, I remember in the original one, from maybe is kind of like a map over option. Um, and I think it's worth here actually looking at the implementation in Elixir because it's very much more straightforward. But I had to make this. I had to make this map maybe, yeah. So like if we have a list of things that might be okay or nil, um, then it's like it's like filter map over the list. Oh God. Um, yeah. We'll
We
figure.
do have this in Rust though.
Mm-hmm.
This is essentially like if you have like none dot um, is it
Map.
map or
Mm-hmm.
yeah from maybe is the same as map or. So you give it a default in a function, and if the option is none, it just returns the default. Otherwise, it passes the contained value to your function and returns that.
Yeah, I'm not. Let's. I want to look at the Elixir one to refresh my
Okay.
memory. So okay, so we're trying to substitute values for the terms in this atom, right? This is so our substitution type up here um, is a mapping from term to term, right? Okay, so what we do is we're mapping over the terms in the atom. So the atom is one of these statements in the program. So it's either like the head of a rule, or it's a single part of the body of a rule. Okay, so mapping of the terms. If it's a var, if it's a variable, we want to find the substitution in the set of substitutions we know. Okay. Um, And if we don't find anything, it remains a variable. If we find a substitution for it, we replace it with the substitution. If
Mhm.
it's a symbol, we do nothing. And then we're returning a new atom which has those terms replaced. So I think this is maybe that from maybe was a little bit confusing in because it's Haskell-y. So
Mhm.
we can probably do this more straightforwardly. Let's go ahead and make that function. Um,
Sure. You want to
uh,
just toss that on Atom or?
no, let's just make it at the top level first,
Okay.
and then if we need to make it a method, then we'll make it a method. Okay, so this is going to take an atom, and we want to take a reference to that. I don't think we need to because we're going to do lots of copies here.
Yeah.
Um, and then
I'm going to toss
substitution.
clone onto Atom.
Yep. Thank you.
I'll just honestly toss it onto everything.
Can't hurt. And
Everyone clones too infrequently in Rust as it is.
um, and I think that I would almost be tempted to bring in a crate here, but I'm not going to. Um, derive more
Which
is
one?
an excellent
Oh,
crate
yeah.
because we could derive deref and deref mute on all of these tuple structs really easily, but it's okay.
Mm-hmm. Want me
So
to just quickly derive or implement that or?
sure, why not? And I'll work on substitute. So okay, so we're going to make a new set of terms, and we're going to copy the predsim. Um, so let's do let mute atom with atom.clone. So we're going to keep the atom has a has predsim, right? So it has the name of the atom basically, and then we're going to replace at the end. We're going to return atom, and then let's do. We're going to make the new set of terms, and we'll say atom terms equal terms, and we'll return the atom. That's basically what we're going to do here. And I can probably do this more efficiently, but we'll figure that out later. Okay. So this is going to be atom.terms iter map, and this is for each term. And we need to collect. Okay. How are you doing there, Quinn?
Oh, done.
Awesome. Um, I don't think you need a deref term because it's going to
Oh, do we
return
just
another
want to put
user.
rule in
I meant
Atom
these tuple structs. Uh,
Oh, you mean going down to the? Okay, I see.
yeah.
I thought you meant for direct coercion.
Okay. I don't know what you mean by that. Oh, you mean
So you don't
the
need to
auto
manually
deref
like,
that the
yeah,
compiler does? Yeah. Yeah.
since it's not going to have a default implementation for the tuple structs, right? So you have to like manually dereference things.
Mm-hmm.
I might be wrong about that. I'm not positive.
Yeah, I just meant like we didn't on like program and knowledge base and substitution we didn't have to do dot zero everywhere. But
Oh,
it might
gotcha.
make sense to instead like make a method on substitution, for instance. I'll start there, and then we don't need to worry about the deref. All right, so what I want to do here is I want to look up um, in the substitution. I want to look up the current term. So what did we do in Elixir? Okay. So we need to do match term with this. So it's either a var or a sim. So if it's a var, we need to do something. If it's a sim, then we can just return term if that's not consumed. And actually, we need to clone it.
Yeah. Do you want to look at function on substitution?
Yeah, we can do that next. I just want to get the essence of this algorithm, and
Sure.
then so we want to do, and this is what you were saying, the map or. So like if we don't find it in substitution,
Yeah.
we'll just use the original, um, and we might use map or else so that we can lazily clone. Um,
Yep, that makes sense.
okay, and then so let's do substitution, and I'm gonna pretend that it exists. Look up v, and then and actually we want to do, so that is term to term, so we're still using the whole thing there. Dot map or else. Is that the thing on option? The most used documentation pages for me. Map or else. No, that's not what I want.
So it's the default and then the function.
I want unwrap or else. v.clone. That's what I want.
Yeah.
And actually, it's not equals there. It's v at like that. Okay. So yeah, let's go ahead and make that method. Look up. Just make everything pub. I don't care. Self, and this is going to return an option. Oh, and this is the other thing that we probably want to.
Do we want substitution to actually be? Oh no, sorry, we didn't make a separate structures for or separate tuple structures for var and sim.
Right.
I was wondering if it should just specifically be a substitution of variables, but we don't have that new type, so it's fine.
Yeah. Okay. So here we can do, and then we need to like iter.
Probably find.
Find. Okay, and this would be, we've got a key and then value, right? This is
Yep.
very inefficient data structure. Key, and actually I should say equals key, map, and here we're going to take the second one, v. That's going to return v. Does that look right?
Yeah. I think there might actually be find map if you care, but
We
might
can try
be
that.
wrong about that.
Yeah, let's
Yeah, there's a find map.
Okay, let's do find map.
Which just, I believe that returns either none or some mapped value.
Right. Let's do that. That's better. We can even be fancy with it because we could say k equals key, and so that should be a bool, and then no, what is it?
No, it would have to.
Bool.
It would have to.
Then it's dot then.
Can you do that?
Yep.
Oh, okay.
Yeah. Then
Some v.
some v. Cool. Okay. So now we've got to resolve some issues down here. So we have incompatible types, and it has to do with my unwrap here. So I think what I want to do is, so if we, this gives us an option of term, and then, because what we want is
Cloned.
cloned, and then unwrap, or else v.clone. Okay. Reach.
Uh, oh, I accidentally left these ones up here.
Oh yeah, we don't want to deref to self. Cool. Okay. So I think that covers substitute. We could probably make a little test here, right?
Yeah, let's do that.
Okay, so we have to construct some of this goop. So maybe we can take something like some of this stuff. Let's see here, because this is about taking a rule and substituting in, or an atom and substituting in the bindings that we've already discovered, right?
Hmm.
So what I want to avoid is trying to create a bunch of this already. Maybe let's take this. Okay, and let's say atom is this. Let's say substitution subs is, and we want to say term var.
We could also make a substitute over a vector of terms because we don't actually care about the atom.
Yeah, but I think that we might. Um, so that would actually just put on the caller the responsibility of cloning the atom. So I don't know, because you're making a new atom with the substitutions in place.
Hmm.
Huh. Maybe we can defer that for now.
Yeah, that works for me. They're both more or less the same, just depends on where you want the boilerplate.
Yeah. Okay, so we have a term var, and we want to bind it to a term sim, and we'll just say we'll use our own names here. And Quinn, you can be X in here.
Nice.
Okay. And these need two string. Sorry. Okay. And so now we want something. We derived partial equal on all these, right?
On term, we did.
Okay.
Yeah, rule's the only one that doesn't.
Okay. Yeah, that's
And
that's
knowledge base, actually, which we're going to want to implement that ourselves later. But
yeah, probably. Yeah, because we're gonna have to do the fixed point.
yeah,
Okay, so what I want to do is do assert EQ, um, and I want to kind of copy this, and we're going to do our substitution here on our own. We're going to say this is term sim, because we substituted X for Quinn,
hmm
and then um, we're going to do substitute and atom and subs. Okay, so let's run that test. It passed. Yay. Okay. So that works as we expect. That's like the very first, like that's the most basic thing that you do in unification. And then now we got this crazy unify function,
Mhm.
which I had a lot of trouble reading. I think the first 10 times. Um, but if we look at the Elixir version, I think it becomes a little bit more clear. So unify is always between atoms, and it either returns a valid substitution or nothing. So we can use option there. Um, and substitution type, did I define that? Yeah, so we're returning a whole list when you unify. You're returning a whole list of substitutions because you're substituting a whole atom, so it could be any of the terms that are in its definition, any and all of them.
Yeah, we have to be a little bit careful here though, because there's going to be lists of substitutions later, which are separate from a single substitution over multiple variables.
Yes, and
So this is just returning one substitution, but it may be over multiple variables.
correct. Yep. So actually, the unify here is there's actually different. I split this in Elixir into multiple different functions. There's the two arity version. Aha. And what it does is it calls the private version, which zips the terms together.
Ah, gotcha.
Right. And I don't think that we need to. We should look into maybe doing this more simply in Rust, because some of this, it could get a little bit confusing. We could do this as like a match, probably.
Yeah,
Um,
that's what I was thinking.
yeah. Or have we could it actually might go closer to the Haskell version where we have a closure inside
Hmm.
that just has the match inside it, and then we have a loop or something. I don't know, but so
Uh, it would have to be a recursive closure because in the variable symbol case, you first unify the rest of the terms, and then you
mhm.
check whether the result of looking up the current variable inside the incomplete substitution is the same as what you started with.
Hmm. Um.
So probably not a closure, but we could define like an inline function or something if we wanted.
Mhm. Uh.
I'm guessing we don't want to bring in the Y Combinator here.
Yeah. Yeah. That would be a bit much. um. Right. Okay. So in this case, I'm looking at the Elixir code here too about what's going. So if we get, so this is sort of like a map over if we were able to unify the rest of the terms. Um. Uh, yeah, the pairs of terms.
Do we just want like two functions, unify and unify pair?
Yeah. Let's probably start with that. So let's make unify, and this takes a.
Our unify pair is actually not quite right either because it takes the entire list, but
Um. Yeah. I mean. Okay. So sorry. This.
wouldn't be a one-to-one port at least.
Yeah. And this is going to return of option of substitution, right?
Yeah. And
Um,
just for anyone who's watching who's not quite sure what this function actually does, it's meant to take two atoms where the first one is going to have variables inside of its terms, and
mm-hmm,
the second one is only going to have symbols. So that's something we call a ground atom.
mm-hmm,
And it's basically going to either return the substitution that replaces the variables in the first atom to make it equal to the second atom, or like more equal to it, possibly with some variables left unbound,
Hmm.
or it's going to return none if those two atoms cannot be like matched together like that.
Right. So, and that shows in the clauses here where we actually have an exception raised if the right hand side has a variable in it,
Yep.
because we assume it to be ground, right? So
Hmm.
so we can probably I don't know if it like makes sense to do it like this in Rust. Yeah, maybe we do something like let's see a
So the
dot.
other way to do this instead of uh, the part that makes it a little bit tricky here is the way that it's like not tail recursive in that variable symbol case. It continues the recursion and then does something with the result before returning.
Hmm.
But we could just have that like accumulator that we pass forward and honestly probably just do like a for loop over the terms in the atom with an accumulator of the bindings or like the
Hmm.
incomplete substitution, I guess.
So here's a well, and this is like right recursive on the list, right? So
Yep.
um, do you feel like the order of iteration matters at all, or is this
No,
just
the only difference would be if we had like error reporting with like diagnostics saying
hmm
which bindings were like conflicting. It's a case of whether it's like the first or the second one that we would hit that error case on.
okay,
But semantically, it doesn't matter what order we do things in.
right? Um, well, and I think that because I think this case where you have two symbols here that don't match is
Hmm.
like the base case to where you should return none,
Yeah.
right? Um, but otherwise, we do want to kind of accumulate, and if the symbols are equal, you just go next.
Hmm.
Okay.
That's really nice and easy to handle with just like a for each in Rust, though. You can always early return.
Yeah, yeah. Let's do it that way. So I made this zipped iterator of the terms. So
Hmm.
let's say uh, a term and b term over that,
Okay.
um, and then let's say subs is substitution default,
Hmm.
right? Um, and I mean we could do dot reverse here, but I guess it doesn't matter that much. Um, and then we should match, right?
Yeah.
And here, let's just say terms or pair, match pair. Um, and this is where we can do term if it's
You could actually have Rust Analyzer fill that all out for you if you want.
yeah. Let's do it. Fill match arms. Okay, so on, but we can also eliminate some of these because if it's ever a
Yeah.
var, um,
If the right side is ever a var, I
if the
believe.
right side is ever a var, so why don't I move those two clauses next to each other, and then we can ignore this, right?
Yep.
Then we should panic, and say the same thing like the
Do we want
sub.
to just pull in anyhow or something?
Ah, fuck it, let's panic.
Sounds good.
Is assumed to be ground, and I'm not going to even inspect that. We'll just panic that. Um, okay, so that covers that case.
Mhm.
and then so for when it's a symbol and a symbol, um, we have derived partial equal on term, right?
Yep.
Okay. So S, let's do S1, S2, and then um, if S1 equals S2, um,
Just continue.
then we continue. So maybe we say when we handle this case where not equal, and then we return none. Um, and we're going to need brackets around that, right?
I don't think you will actually.
And it's going to say, yeah. So and actually out here we're going to return some substitution subs.
Hmm.
Okay. But now we have an unhandled case where they are equal, which honestly at this point I would just say we do unit there. Um, so now we have to handle the case where we're actually doing a substitution,
Hmm.
which is the bit that we had in here, right? Um,
Yeah.
okay, so we are. Let's label these. I don't really like using this syntax very much, but we need it for the matching as well. Um, so if we have a variable which is should be matched up with a symbol, we want to see if that variable is already defined in the substitutions we've accumulated, right?
Yep.
Um, actually, I think we might have a problem here in that um, we need to be scanning. We need to be doing that recursive unification, right?
Well, we can just, I believe, always bind, like add the current bind, look up the value that's currently there, and then insert whatever we want, whatever the current binding is into the end of the substitution, and then just fall through, and it will continue to the next iteration of the loop, and then everything's fine, right?
Well, I was mostly thinking about like how this unifies over the rest of the terms in the atom, right?
Mhm.
Before it tries to see because it wants to check that we didn't unify it to two different values.
Yeah, but that'll just happen when the conflict happens. In our case, it's going to happen like the second time that you bind a
Okay.
variable instead of the first time.
Yeah. What about cases where you have, say, the. Yeah, I guess it doesn't matter. Yeah. Okay. So we could say if subs look up.
Or you type that. Want me to just start writing a quick test for that?
Okay, that would be great. Try not to hit save because
Sounds
it
good.
reformats everything.
Gotcha.
Uh, okay, is sum. So if we or have a value for it, no, let's do match. Match subs dot lookup v. And if there's s2 term sim, if s2 not equal to s, then oh right. So if we ever hit the point where it's bound to two things, we say there's no valid substitution, and then
Hmm.
return none. That's the other bail. Otherwise, Um, why don't I don't know if I can do that with an if let. Maybe I'll see if Rust Analyzer will refactor it for me. Okay, so otherwise we do subs push, um, and we give it vs. Oh, this is some. All right, let's see if Rust Analyzer can. Oh. Okay, so that's some gnarly code.
See what we have here. So I look up if
The nested matches are
in
what are
there,
bugging me.
and it does not match, then none. Otherwise, oh, it's correct to me though.
Okay. So you wrote a test, or you're
Yeah, there's in theory two tests. I think I'm probably missing a bracket or something. I didn't want to hit save while you were coding.
okay? Well, let's hit save and see what happens. Okay. Closing delimiter probably meant for this.
Oh,
Let's see if we can get some.
oh, there's another parenthesis here needed, I think.
Okay.
So, oh, yeah, gotcha. I was missing this one here, which means there's now too many here. I feel like I'm writing Lisp.
You need par edit. Oh man.
Yeah, and then I had the same mistake on the first one.
Sorry. Aha.
Here we go.
Okay.
And unify takes the references. What is this now like? Oh, right, because this needs to be substitution.
Oh right.
What is it now like now? Oh, we never defined equal on partial or equal on substitution. Let's do that.
Sorry, folks, if you can't see what Quinn's doing, jumping
Oh,
around.
sorry about
That's all right. I'll
that.
follow you for now while you're doing that.
Sorry, I forgot that it was your screen that they can see.
It's quite all right.
Okay, cool. So the push down here is failing. Yeah, we just need to
Clone those.
clone.
Yeah. Okay. Oh, subs dot zero dot because we didn't define deref mute for substitution, but that's fine. No big deal. Here, let's just do it.
Oh, deref mute. Yeah.
Don't do this at home, kids. It's not actually a smart pointer. It's just a double struct. Um. Okay. So your test is done now. Let's see if it'll pass. Boom.
There's two at the bottom there.
Nothing failed. Okay.
Nice.
Right. Yeah, let's talk about why this one should return none, right? Because you have
Yeah.
This is an assertion that the two pieces or the two terms in this atom should be equivalent. So x equals x. You can't have any other value for x, and you have Alice and Bob are different names there, and so they can never match. Congratulations, folks. You now understand how pattern matching works with unification. Cool. All right, so that wasn't so bad. We got unification and substitute. Let's look at what he says to do next. So we did unify. Okay, so eval atom is a big one with a monad in it, and I think this is the one that I had trouble with first time around. And there's that evil map maybe, which
Hmm.
we can probably get around with Rust's built-in stuff. Um, but okay, so eval atom is a function that takes a knowledge base and an atom. So knowledge base would be, go back up here to the top. Stop. Oop. Okay. So knowledge base is a vec of atoms. So these are the things that have already been determined. It takes a list of substitutions. So that's not a single substitution list, but a list of substitutions. So we're talking lists of lists, basically. And then returns a new set of substitutions.
And so what this is basically saying is that if we have a database with, say, three facts in it, and we have a rule with an atom that is going to match against those facts, that's going to expand out to potentially three different substitutions for the different bindings of
Mm-hmm.
the variables that map to those facts in the database.
Right. So this is like in the process of evaluating a rule, like the atoms inside the body of a rule. Is that correct to understand that this is where this is applied?
Yeah, exactly.
Okay.
Later on, when we're evaluating the rule, we will be walking across each of the body terms, which in the simplified version of Datalog, each of those body terms is just going to be an atom.
Mm-hmm.
Uh, so this is just very bottom up way to implement, I guess, bottom up Datalog. But if
Yep.
you don't know where we're headed, these pieces might seem a little bit arbitrary.
Yeah, and I think that's one weakness to this blog post is he doesn't exactly say at all points where we're going or like what's the step after this and why we need this. So
Mhm.
yeah. Okay, so let's make an eval atom function since we're just doing it like we did in Elixir and Haskell. Eval atom. So looking at the signature here, this is going to take I'm gonna call it KD
Knowledge base,
knowledge
atom, and
base
a set of substitutions.
atom and sub, and this is a vec of substitutions, or maybe we could say it's a slice because we don't care,
Yeah.
right? And
And we've been abbreviating a single substitution as subs everywhere. So I don't know if there's a better name.
so maybe this is like, because this is sort of what are the possible sets of substitutions we want to apply, right?
Mhm.
Um,
Subs is.
subs prime? No, it's not. Yeah, all subs. There we go. Or
Sounds
we
good.
say, or like known subs or something like that. Okay, so right. Okay, so this is monadic notation for we are walking across all of the substitutions that we were passed.
Yeah.
So this
Probably easier
is,
to read this as like a for loop.
yeah, for sub in all subs, right? Okay, so we can start
Yep.
with that. And then we'll say let down to earth atom. um, and this is where we call
So the reason they
substitute.
use this name, I mentioned earlier that if you have an atom where all of the terms are symbols instead of variables, that's called a ground atom.
Mm-hmm.
So I guess by down to earth atom, they mean one that's like closer to ground than it started.
Mm-hmm. Okay, so right, and so then they're trying to, right, they try to unify this atom with all the entries in the knowledge base. That's what this map maybe is. And so if any at any point unify returns nil, it skips it and goes on.
Yep.
So right, so this is trying to create a new set of substitutions.
But it does so by potentially extending each of the substitutions that we start with.
Right. And I think
So
yeah, go ahead.
so if you have I don't know, like an atom that has two variables in it, x and y, and you have a substitution that is only substituting the variable x, this might potentially result in like a new substitution that replaces both x and y.
Mm-hmm. Yep. Yeah, and just to make it more clear here, let's see eval atom in here in Elixir. So we're also doing a for loop over the substitutions that we're given. We do substitute, and then we do a loop over each of the possible outcomes of unifying that atom with something existing in the knowledge base, and then concat that
Mm-hmm.
with
And that
the
map may
substitute.
be like more rusty, might be doing like a filter map.
Mm-hmm. Um, and then there's this flatten step, basically.
Mm-hmm.
Well, it's not flatten; it's concatenate, so it's like flatten once. um, so we have lists of lists of lists and things here, and maybe there's a more rusty way to do that. But let's start with calling substitute. Okay, and that's going to take add atom and sub. Let's use substitution here, but don't capitalize it.
The more rusty way might be for us to define like extend or extend slice or something on substitution.
That makes sense. Um, but if we have deref mute on it, we can. Mm,
Yeah.
and I guess it will get the iter implementation. So extend requires it's like into iter.
Mm.
Should be able to call into iter on substitution. We'll see. Okay. Um,
And we're gonna want to make sure that we're counting the substitutions here.
yes. Okay. Let me copy this out so we can get it going here. Because I want to stop flipping back and forth.
Mm-hmm.
And I'm going to actually just copy this entire Haskell code in here so I can see it. Except it's not filling in comments like it did for me on. Oops. Okay. Right. So we're not returning that yet. We need to new subs.
I'm just gonna rename all subs with an underscore to match.
Thank you. Okay, so if this is the, I'm gonna move this up so I don't see the syntax error over the comments. um, okay, so we're looping over all of the available substitutions, and then we compute the down to earth atom. So try to substitute what is
Mm-hmm.
known in this particular substitution into that atom. And then, right.
Oh, we have
So,
a mistake in unify actually.
oh yeah.
Uh, yeah, we need to make sure that both atoms have the same pred sim.
Oh, we need to make sure they have the both same pred sim and the same length of
Yep.
terms. Um, right, and I think maybe in the Elixir version I didn't I didn't even cover that.
I was going to add a test for that, but that's just a quick check at the start.
Yeah, so we could say, well, and this will actually crash in Elixir if the terms have or if the atoms have different term lengths. Oh, no, it just returns no. Okay, so if a dot predsim not equal b dot predsim, or a dot terms dot len not equal a b dot terms dot len, then we return none. Okay, thank you for calling that out.
Mm-hmm.
Um,
Since now, thanks to that, we can just iterate over all of the knowledge base, and I think probably just write things a lot less terse than they did in the Haskell, and it'll be pretty straightforward.
okay, so we need to do we need to make a new, like this is extension, right? And the goal here is to combine the existing substitution with that extension.
Yeah,
Okay, so we probably,
I'd probably iterate over the knowledge base for
yeah.
each atom. Try to unify the down to earth atom against uh, the one that we're checking, and then if we get back a substitution, we can extend the one that we're currently iterating over with that extension.
Mm-hmm. What if we
I don't
did?
actually know if we. Oh, sorry. What are you doing?
No, I don't actually. I don't think I want to go that way. What I want to do is do
Okay.
KB. Um, I want to do a let extension equals KB dot iter map. And so here we're gonna have, right, because this map maybe is like saying, is basically this function that I had to do here. Like if we have a list, it's like filter map, right?
Yep.
So let's do filter map. Um, and yeah, that's essentially what this is doing. Okay. So we get, and let's just call it an entry. I don't have any good word for it. I think it's just I in this one. Um, okay, so we have we try to unify down to earth atom with entry, right? That's
Yep.
that's what the Haskell version was doing here. Unify down to earth
But
atom
this
with.
is actually going to be a collection of substitutions.
Yep. Um, oh right, and we had, because of the freaking monadic whatever, what we
Yeah.
need to do here is
Yeah.
so
In the
a
Haskell
map,
code, we're in the list monad there. So whenever it has the left arrow, that's like
right.
a for loop.
So we need to do something like yeah, let's back this out. This is actually not such a great idea.
Yeah.
um, so we want to have extensions plural, or maybe this is new substitutions. We use that
Yeah.
one.
I don't know if we need an. I think we can just use new subs there.
Okay, so let's do for entry in KB. Then we're going to do let's do match unify. Come on,
Might even just do an if let here, since there's nothing that we do in the none case.
right? This is a set of new subs, right?
Uh, This is going to be the extension.
Yeah, this is okay. So this is extension.
Hmm.
Some unify. Thank you for helping me clarify this. Atom with entry
Down to
down to
earth
earth
atom
atom.
with
Yep,
entry.
and that has to be a reference. Then we do new subs push, and we want to take the original substitution. Um, uh, Yuck. Okay.
This always drives me crazy about Crust.
It's fine. I'm just was like I spent most of the time previously with Elixir and everything's copied, so
Mhm.
now I have to think about it. Um, so as
I mostly wish they
extend,
just had like more expression-oriented APIs for things, like being able to extend and return the extension.
okay, knowledge base is not an iterator. Dot iter. Okay, so this is that concat operation that we were doing here, and we don't have to worry about this because we're sublimating the return value of this 4 into this new subs vec.
Mhm. This looks correct to me.
Can we improve this? Maybe I could do um, maybe I can do this as uh, iterators with chain. I don't know if that's any better than this crazy extend clone stuff. What do you think?
Hmm. Yeah, you that might not be the worst. Uh, what just substitution dot zero dot iter dot chain extension dot iter dot collect. That they're both kind of funky.
Yeah. Let's let let's put it, let's see if that we can make that work real quick. I'm gonna just put it in line here. We'll say substitution dot iter chain extension dot iter collect.
Dot clone.
Iter cloned.
Uh, it might have to be after the chain.
Okay. Oh yeah, because extension is going to return references as well. I could. The thing is, though, we could consume this. We could do into iter, but I guess it doesn't matter in this case. That's not
Yeah,
so bad.
we can do it for the extension.
Right. What was it complaining about there?
Probably got to remove that other clone.
Oh yeah.
Do you have to do like deref mute here, maybe? Hmm.
No, because is it just that? Yeah. I don't know.
I like this.
Okay. Okay, so we got I guess we need some test for eval atom, don't we? Um
Yeah, let's do that. I'm just gonna copy the advisors out of that first test and make a knowledge base of them.
Okay.
What's KB? Is it a list of atoms or vector of atoms?
Yes.
Check of atoms. All right. Okay. So we can use that as our knowledge base, and then I don't know. Let's start with a substitution of x against one of those and y against one of those, and then we can unify an atom of x and y against that, and that should give us all of the combinations of the substitutions for all the combinations of atoms that have that x and have that y.
Okay. You'll have to show me because I didn't exactly
Okay.
follow. All right. Are you saying like let's just have an open atom that has x and y in its terms, and then
Yeah.
find all the advisors basically.
And then we could start with two substitutions, one that binds X to one of the advisors and one that binds Y to one of the students.
Mm-hmm.
And then that should give us like the combined set of all substitutions for those advisors and also for those students.
Okay.
Oops. So I don't know, let's say David Wheeler. That's how to be term sim David Wheeler. I cannot type.
I'm gonna have to make a declarative macro for this. Anyway, go on. Go on.
What isn't it like about this? Oh, I keep forgetting to close these. Okay, and then we want another substitution in there. And this one can be Y with one of the students. And let's do Alan Nicroft because there's two of him.
Mm-hmm.
What's going on there? Oh, right, yeah. Do you see what the mistake is here? It's telling me it wants a semicolon, but there's a semicolon
It's
there.
on the first one. We're missing that somewhere. Sorry, I'm going to do it the old-fashioned way. Okay, so this would be made much more simply if I had done that macro. Okay, so that should close that term, and then we need a bracket, and then we need a paren, right?
What is this square bracket?
That's
Oh,
for
I
the
see.
end of
That
the
vector.
internal vec, yeah.
Yeah, that's right. Yep, yep.
Tweak that a little bit and see if I can find out where the problem is. Oops, I meant to do that.
If you hit save, is it good now?
No.
No?
No. Okay. So. Oh, wait. We need another paren there. Okay, I think it's okay, but it didn't reformat any of that. So let me see if it, no. Okay, so it didn't like. Oh, we don't have a fun here.
Yeah, let's just hit the. Oh, did I just not write fun?
No, I think I may have written it and it got deleted somehow.
Hmm.
So fun eval Adam. I don't know. We'll just call that. That's bad. Adam test. Okay. Now we've got formatting. Cool.
Okay, cool. So now when we run this, we should get, I believe, 3 substitutions out. David Wheeler, Andy Hopper, Rod Burstall, Alan Mycroft, and Robin Milner, Alan Mycroft.
So you want to just debug that in here, and then, panic at the end.
Sorry, what do you mean?
Do we want to write assertions right away, or should we just debug what the output is and see if it looks right?
Oh, yeah, we can do that.
Okay. Eval Adam. KB Adam all subs. Right?
Yep.
What's wrong?
Semicolon.
Yeah, but there's something else wrong. Knowledge base. Oh, it takes a reference, of course.
Oh, the KB here.
Oh, it's not actually a knowledge base, it's just a vec. Yep. Cool, thank you. We can remove that.
And then you're going to want to panic at the end.
Yep. Okay. Let's see that run. Cargo form. Okay, cargo test. All right, so what do we get? Got a substitution
Yep,
where, okay, so we extended Y with Andy Hopper and X with Rod Burstall and X with Robin Milner. Does that line up with what we expected?
Yep.
Robin Milner, Rod Burstall, Dominic Orchard. No, that'd be if Y. Okay, so
Yeah.
we had Y as Alan Mycroft, X as David Wheeler. So David Wheeler had Andy Hopper. Yep. Okay.
Do you want to just copy paste that in then?
Yeah. Oops. So
The part that isn't shared with me and Zed is the terminal. So
okay, I will copy paste for you. So let's comment these out and go assert EQ eval Adam. Yep. And we're going to do, and I'm going to paste this, and it's not, yeah, it's missing an opening bracket. And I have to put the vec back in everywhere. Okay, and then it reformatted it nicely. And that's right. Oh, I messed it up. Okay. And we're going to have to do all the two strings. So, yeah, I think in the interest of future um, things here, maybe we should go ahead and make that declarative macro.
Mhm. Yeah.
Then we can make more terse tests and not have to be frustrated at this two string everywhere. Okay, cool. So let's run the test real quick. Cargo test. I'm pretty sure it's gonna work, but yeah. Okay. Cool. Um, so
We're almost through this.
we're almost through. Let's look at what he does next. So then he says walk the body and accumulate substitutions and use these substitutions we deduce new facts based on the head of the rule. So um, given a knowledge base and a list of atoms, return a list of substitutions, which is just a fold.
Mhm.
Okay, so I think we can do that as a function. Start putting them at the top here, it doesn't matter. So walk is going to take
Knowledge
KB, a
base,
knowledge base.
slice of atoms, and return a vector substitutions.
Okay, slice of atoms. Um, and right, it's going to return a vec of substitutions. Okay. And yeah, that's going to. Okay, so right. So the question here is, I guess we can do iter. Um, I've never used reduce or is it fold? Now, one
It's
question.
reduce. They have
It's
both, I believe, but reduce is the more common one.
the question in my mind though is um, because what we want is for each of these.
I think actually fold's probably the one. I think reduce doesn't take an initial accumulator, and fold you get to specify it possibly.
Right. Oh, but I'm doing this wrong. This is we're not walking over KB. We're walking over the list of atoms. So let's call this atoms.
Yeah,
Um, uh, fold, and that's going to take an init of default.
substitution default.
Yeah, we can just be more explicit about it. Default, and then right, and then
Yep.
the function is going to take.
It'll take an atom, and we will do eval atom with the KB
It's gonna
and
take an atom and the substitutions, right?
oh, sorry, the fold. Yeah,
Yeah. Um, and then I think we need to collect on the end probably. So this is going to call eval atom KB atom subs, and let's call this all subs just to be clear. Okay, what's wrong here?
all subs. I think the arguments are flipped. I think it might be all subs atom.
Oh, okay. Oh, this needs to be vec. And now, what's wrong here?
Because eval atom is we don't do collect, I think, because fold is just going to return the vector substitutions.
Okay. Thank you.
Mm-hmm.
So okay, so that's interesting. There's a question in my mind here about whether this is maybe we don't need to bother with it. But this looks suspect to me because we're going to be. No, I guess we clone a lot. I don't know if there's any way around cloning here. Um, in
RCs.
Yeah, but I mean more like this. This all subs. Um, each call to eval atom, there's going to be another clone, at least one. So okay, but this is actually pretty easy to understand at that point. So walk, and then we need to do eval rule. Let's do eval
Yep.
rule. Um, Eval rule, and that's going to
And that
take
is,
a knowledge base again. Oh, whoa, whoa, whoa,
yeah,
whoa.
knowledge base and rule and returns a knowledge base.
Okay, and rule takes a rule, and we're going to take a reference unless otherwise instructed, and it's going to return a new knowledge base. Okay, so got it. Okay, so given a rule, so this is a partial application substitute head, right? So
Yeah,
we want to do.
we're basically going to map over the result of calling walk.
Right.
And for each one, we're going to substitute it into the head of the rule.
Mm-hmm. KB, and
And
so
Adam's here is rule.body.
yeah, so this is rule dot body. I guess, do we need to do that?
Yeah.
Okay, and then we need to into iter map, right? Substitute.
Yep.
Okay, so this is going to give us back a vec of substitutions. Um,
We can do substitute rule.head subs.
and then we need to collect. Okay, what's wrong here? Arguments function are incorrect. Rule.head is.
You did into iter, so this is an owned subs.
Oh, right. I guess we don't need to do into iter, do we?
Shouldn't.
The only question is whether, that would live long enough. We'll see. Help me out here, Rust Analyzer? Come on.
And this is because we have the new type. So we need to wrap this in a knowledge base.
Oh, right. And it just blew that away because it's so helpful. Yeah. Okay. Okay. Cool. That wasn't so bad. Okay. So now, now the fun part. I remember trying to parse this point freestyle goop the first time and getting really
Yeah.
frustrated.
I am just going to write a quick test for eval rule.
Okay. Let's see what you're doing. Feel free to save whenever you want, by the way.
Sounds good. Um, So this should be a rule that just projects the first column down to a new relation. So then if we do assert equal, we can
Mm.
say,
Oh. But we have a problem there.
what's up?
This implementation assumes that rules are range restricted. Um, so you can't have free variables in the body.
You can in the body. You can't have free variables in the head. Or at least that's how range restriction should work. And if that's not what we implemented, then we did it wrong.
Yeah, well, I mean, I'm trying to say we might have done it wrong, but I was looking at. Oh, right. Okay, no, you're right. So it's right. All the variables in the head have to be represented in the body. That's what it is. You're right.
Yep.
Okay. And I actually thought I had forgotten about this, but what might be useful is to, um, uh, do the make invalid states unrepresentable,
Mhm.
and for the constructor for rule, make sure that all of the variables used in the body are, or all the variables
Mhm.
used in the head are in the body. Anyway, go on. You're
That
fine.
makes sense. And we can't directly compare knowledge bases yet. Do we want to derive equal on that?
I don't see why not.
Okay. And you can actually quickly jump to following me if you hit like Command Shift Control F, I believe.
Mm-hmm. It's like all the modifier keys plus F.
Mhm.
Okay.
Very cool. How's that test
All
go?
right. Let's see. It passes.
Cool.
All right. So, okay. So now we're doing immediate consequence, which is essentially run the program once, producing a new knowledge base against an existing knowledge base, which should be straightforward.
Hmm.
Okay. So we'll just go ahead and do that. Immediate consequence. And this one, I think, was really frustrating to read, but I think has a really simple solution in Elixir. So I'm going to go read that. Okay, immediate consequence. Right. Rules, map over them eval rule, concat, and then unique.
Yeah. God, that Haskell version's terse.
Oh, God, yeah. Right.
What is it
So,
saying? It's saying can cat map over the rules for each rule evaluated with the knowledge base, and then that gets catted onto the end of the existing knowledge base, and then you dedupe that. Okay, yeah, so the same thing you're doing in Elixir, just not written in Alien.
yeah. And this concat map would be flat map, right? We're gonna
Yep.
do flat map. Okay. Um, and this will be so that's a rule. I'm gonna do eval rule, knowledge base that collect, and then so the question is, I guess we can say let Okay, so we have the new knowledge. That's should be a that should be a vec at the end.
Yeah.
Um,
If we want to get clever here, we could do kb.chain or kb.clone dot chain, all of that, and then dot unique.
mm,
Oh, unique is in iter tools.
oh, okay. So we probably need to. Okay, we're gonna do new kb equals kb dot clone, and then we're going to do for, and then we'll maybe we can inline that later. For fact in new knowledge,
Hmm.
um, if contains fact, just do the straightforward imperative way, and then we return new kb. And this is not correct yet.
And I'm actually generating batch to Atom just
Thank
because
you.
batches are specifically rules with no body.
Correct. And then let's inline that variable. Um, and we don't need to collect. Um, we need to clone there. Isn't that what the problem is?
Yeah, and program.0.
But program has deref on it, doesn't it? Knowledge base is not an
Um,
iterator. Okay, so this is into iter.
oh, it's not knowledge base, it's program. It does have it, okay. I'm not sure why that didn't go through.
Oh, is that you can't flat? Mm,
Oh, is it the intuitor at the end? Did you just add that, or? Want me to add drf mute?
no, it's fine. Um,
Okay.
let's see. Let's see what's wrong here. Honestly, we probably just do dot zero instead of into iter there. Yep. Okay. Kind of fumbled our way through that. Okay, so we clone the existing knowledge base to create a new one. The interesting thing here is, though, with the immediate consequence, we could consume that knowledge base.
Yeah.
And then we don't have to clone it. Because the very, like, this is in service of the fixed point.
Yeah. That sounds good to me.
And then, and let's do mute. I hope that's not going to cause problems of overlapping borrows, but yeah. Yeah, that's
Yeah. You could toss this stuff into a new vec and then extend it.
mm-hmm. Yep. Okay. So we'll do we'll still new knowledge. Vec. And then we'll say new knowledge dot push that. Thank you. Extend new knowledge or dot zero dot extend. Okay. The other crazy thing I was thinking of doing is, oh, let's make an RC and push it into the closure.
Hmm.
That would be a waste. Um, okay. And I think we probably ought to wrap pretty soon, but we are so close to the end. Oh my gosh. Um,
Yeah, solve shouldn't take long.
okay, the question is fixed point. And this may be the other reason that we don't want to consume. Um,
Oh, right. Um, yeah, we need the old one with the way this is being done.
the other possibility we could do is change this up a little bit, and yeah, and I agree. We probably need. Um,
Like this could return a Boolean since we
I was
already
gonna
have the
say
immutable
make an
reference.
option knowledge base of a new knowledge base.
Hmm.
And then if we get to the end of this loop and new knowledge is empty, then we return none. What do you think?
Wait, is it even going to let us return an owned? Oh, right, because it's taking. So we are going to want the knowledge base. So if it's taking an owned and we
Yeah,
return a none, we're throwing it away. But
yeah,
then we can't return the owned version too.
yeah. So
Uh,
I think what we want is this, and we'll do um, okay. Uh, if new knowledge is empty, return none. Well, or we can just say none. Else, we'll say, and this kind of does this will do the fixed point for us, right? If we didn't learn anything new, then
mhm.
we'll do some. Okay, let's see, iter cloned uh, chain new knowledge iter
Okay.
collect. Ah!
Okay. Yeah.
um, and then we need knowledge base around that. And I actually like this is one of those cases where I'm like, I wish we had implemented from. Um,
And here I think we actually want to move the cloned after the chain.
okay. Oh, you're right. Okay. Whee!
Oh, all right.
Okay. And then so our I don't know that do we want to implement that range restricted check?
I was going to suggest skipping it if you wanted to wrap up soon.
Yeah, yeah. I think I want to wrap up. So
We
what
can
we'll
just
do
stick
is
a
do
comment in
solve.
there.
Yeah. So solve, and this takes a program.
Program to knowledge base.
Okay. And then yeah. So and this will be like a um,
And the Haskell version is computing the fixed point, but I feel like we can just do like a loop that we break out of when we get none
yeah. I was
back.
gonna say like a while let um, sum
Yeah.
kb sorry equals
Well, we want to return the knowledge base. Uh, and a while let isn't going to give us access to the last value outside the loop, right?
Right. So we let's do knowledge base default here because we have to
Yeah.
start with something empty. And let's make it mute. Um, and then while let sum kb, well, we need to new kb is immediate consequence of program in kb. Then we say
I
star
was thinking
kb
we could
equals
just
new
do
kb
a loop here and then return out of the loop when we
when we get none.
get back none.
Okay.
Or, okay, this works actually what you have.
And then we'll return kb.
I didn't realize you were gonna like deref a sign.
I don't need to deref a sign. Um, there's probably some better way to do that, but yeah.
Yeah, I think that's it.
Okay. I will commit and push this off stream. Thanks everybody
Yeah.
for attending, and thank you, Quinn, for
Yeah,
like
no, this was great.
leveling
Do we
up
want
my
to run that
Rust.
first example?
Yeah, let's run that. Which first example?
So we wrote an example inside the tests, and now we can run it. The very first test we have.
Oh yeah, yeah. So let's do let's debug solve
And yeah, no, thanks for the invite. This was an awesome time.
program, and let's make the rename this variable. Yeah, and thank you for everything on this, and I hope folks who stuck around enjoyed this change of pace from Elixir. And, okay, and then we need a panic at the end of this, so it prints out. Okay, let's run that test, and it's going to be a bit big. Actually, I want to change the way that prints. um, Rather than debug, let's just do panic format without the fancy multi-line. See how that works out. Actually, one thing I wanted to do, but maybe I can do in a future stream, is implement display for each of these types, so we can
Mhm.
actually print it out as a regular program. Um, and yeah, so let's run it one more time. Okay, yeah, so that's not so great either. Um, let's switch back. I'm sorry, folks, for the because honestly, we kind of probably want to print it in our own way in the end. Okay, so you see, we're actually um, getting
Is there like
rules.
a David Wheeler to Andrew Rice in there?
Let's see, David Wheeler to Andrew Rice. Yep,
Cool.
cool.
That sounds like proof to me.
Yeah. All right. Well, this is fun. Thank you again, Quinn, and
Yeah.
everybody. Have a great weekend.
Take care, Sean.
Yeah.